Hi, welcome to class. My name is Don LaFond, Professor Don, and this week in Cisco 2, we are covering Module 7, DHCP v4. Tonight, if you're here with me live, we are also covering Module 8, so please don't go anywhere at the end of this presentation. For those of you only watching this video, it's going to be about 30 to 40 minutes, and we'll cover about 40 slides, not very complex, and then I'll go right into the second presentation and record that as a second video. If you are watching me live, please hold your questions for the end of the presentation, and I will allow for a question and answer period of time. If you're watching this as a recording inside of NetAcad, please ask your questions in the help discussion forum. And if you're watching this on YouTube, please ask your questions in the comments section below, and I will do my best to answer those questions. I'm going to go ahead and share my screen. I have to configure that bar. Start the presentation. And then, all right, here we go. Module 7, DHCP. The objective is to implement DHCPv4 to operate across multiple LANs. I will explain how DHCPv4 operates in a small to medium-sized business network. We'll configure a router as a DHCP server, where it's handing out addresses, and we'll also configure a router as a DHCPv4 client that's requesting an address or receiving an address. DHCPv4 concepts. So Dynamic Host Configuration Protocol v4, DHCPv4, assigns IPv4 addresses and other network configuration information dynamically. DHCPv4 is an extremely useful and time-saving tool for network administrators. This is because desktop clients, which typically make up the bulk of network nodes, do not have to be configured manually. If you can remember back, or if you can imagine back in the day before dynamic allocation of addressing, a technician would have to go from, say, classroom to classroom to classroom, configuring manually each PC to have an IP address. And I've talked to people from the beginning of network, and they've said that it used to be really confusing because if you just have one typo, or if you duplicate an address, it would be extremely difficult to then figure out why it's not working. So manual configuration not only is time consuming, but it also is a source of errors in the configuration. A dedicated DHCP v4 server is scalable and relatively easy to manage. A Cisco router can be configured to provide DHCP v4 services in a small network. So this DHCP server will say, hey, I can provide you an address. And a PC is like, I really need an address. Can you give me one? And sure, here you go. And the handshake happens and they get their address. Pretty easy. Now, a dedicated DHCP v4 server is scalable and easy to manage. However, in a small branch or SOHO location, a Cisco router can be configured to provide DHCP v4 services without the need of a dedicated server. Cisco iOS software supports the operational full-feature DHCP v4 server. The DHCP v4 server dynamically assigns or leases an IPv4 address from a pool of addressing for a limited period of time chosen by the server, or the person configuring the server, or until the client no longer needs the address. Here is your DHCP server, a PC requested, another PC requested. Ultimately, the address hands out addresses to the PCs as necessary for a specific period of time, and I'll show you that. Now, DHCP works in a client-server mode. When a client communicates with a DHCP v4 server, the server assigns or leases an IPv4 address to the client. The client connects to the network with that leases the IPv4 addresses until the lease expires. The client must contact the DHCP server periodically to extend the lease. This lease mechanism ensures that clients that move or power off do not keep addresses that they no longer need. When a lease expires, the DHCP server returns the address to the pool where it can be reallocated as necessary. When the device comes back online, it just requests another address, the server gives it another address, and then it's off and running again for a specific period of time. Now, I want you to imagine the school use. Think about bringing your laptop, bring your own device, bring your own device, even your phones using Wi-Fi at work while you're at work or at school. When you sign in with your Wi-Fi, with your phone, your laptop, your tablet, you need an address, an IPv4 address. It reaches out to the server. I'll show you how it does that with a broadcast message. And it says, hey, any servers out there, I need an address. And the server says, and one or more servers might respond with an address, and then it picks that address. Now, you're at school only for a certain number of hours. You're at work only for a certain number of hours. It would not be necessary, generally speaking, for the device, that laptop, to hold the address for 24 hours, or 48 hours, or a week, or a month, or a year. It's IPv4 addresses, you wouldn't want that at all. We'll learn later IPv6 address, that's a different story. But IPv4, it's okay. It's not okay to keep your address. It's not okay to hang on an address for a period of time. You wouldn't want that. So think about a work environment. Yes, you return every day. You just get a new address every day. Sure, you can have a static address configured to you, but it's not necessary. Then the administrator would have to stop the static address, terminate the static address when you were terminated or you quit the job. Then it would be a manual job, right? That's just extra work. You don't come back the next day, you don't get another address. Easy as that. Now, clients lease the information from a server for an administratively defined period. Administrators configure the DHCPv4 server to set the leases to time out at different intervals. The lease is typically anywhere from 24 hours to a week or more. Or less. It could be like I was explaining as a student. 4 hours is generally long enough. And just because it expires in 4 hours does not mean that it cannot be extended. And that's the renewal period. So let's say most students come to school for a 3-hour class, a long class, hour-and-a-half class. Let's give them 3 hours. And then if you after the 3 hours, if they wanted a new lease, they would just ping the server and request a new lease, and then they would get a new time frame, and that would continue. If, say, you had a long day at school, and you were there for 4 hours, 6 hours, 9 hours, it would just continuously ping. But as soon as you left the campus, it would free up that address relatively quickly. Now, 24 hours, as is given here as an example, that would be overkill, because you're definitely not going to be at the school overnight, and generally speaking, you're probably not going to return within 24 hours. So in a school environment, that doesn't make a whole lot of sense. A work environment, a week, that makes a lot of sense, because you work Monday through Friday. You don't necessarily want to have to get new addressing, IPv4 addressing all the time. So a week would be just perfectly fine. And if you are gone for a week or more, then it resets. But as soon as you come back, you get a new address. Should not make a difference. Now, how do you get a lease? So there's a handshake. And we call this handshake DORA, and it stands for Discover D. Discover D. Let me put on my laser pointer. So Discover D O R A. So it's discover, offer, request, and acknowledge. So DORA, those of you with small children, that's easy to remember. Those of you that don't have children, you've never heard of DORA, go to YouTube and type in DORA and you'll be done with DORA in about 15 minutes. But anyways, if you got small kids, you're stuck with her. Anyways, but DORA, easy way to remember: discover, offer, request, and acknowledge. So how does that work? Well, the client comes online and it broadcasts a discover message saying, I would like to request an address. And then one or more servers unicast back to the PC that comes online. Here is an address I can give you. That's the offer. They're offering an address. And then the PC accepts one address and then does a broadcast back out. Now, the reason why they do a broadcast instead of a unicast is because when they accept this address right here, they are telling the world, I've got an address, I don't need another address. So let's say 3 offers were made here from 3 different servers that responded. Then the broadcast saying I'm accepting this one automatically tells the other 2 that they can put their offer back in their pool of addressing. Okay. And then the acknowledge is from the server saying your acceptance is acknowledged. You've got that address, and that starts the timer. Okay. So to renew a lease, prior to lease expiration, the client begins a 2-step process to renew the lease with the DHCPv4 server as shown in the figure. So again, and I'll show that time frame in a little bit, but roughly halfway through, the client will say, hey, I'd like to renew my lease. And then assuming that the server is still online, then the server says your request is acknowledged. That starts the timer again. Now, if a DHC acknowledge is not received within a specific amount of time, the client broadcasts another DHCP request so that one of the other DHCPv4 servers can extend the lease. Now, on receiving the DHCP request message, the server verifies the lease information by returning the DHCP acknowledge, and again restarts the clock at that point. Now, if the renewal fails, the device will attempt to extend its lease with an active DHCPv4 server during its rebinding period. Should the device still be unable to extend its current lease, that particular address will go back into the existing DHCP pool for reassignment to another device, if the server is even online. If the server is not online, then the server is not online. If the device will likely receive a different IP address should it connect to that network again in the future, the device then begins the DORA process to get a new DHCPv4 server from another location. Now, now let's learn how to configure the DHCPv4 on a server running iOS software the Cisco iOS DHCPv4 server assigns and manages IPv4 addresses from specific address pools within the router. Here is my DHCP server, and we are going to create a pool that is going to give addresses out to any PC and the server, for that matter, that needs an IP address. So let's configure it. So the first step is to exclude IPv4 addresses. Some devices you want to have a static address, and those devices need a range of addresses that will not be allocated dynamically. So a single address or a range of addresses can be excluded by specifying a low address and a high address of the range. Excluded addresses should be those addresses that are assigned to routers, servers, printers, and any other device that has been or will be manually configured. You can also enter the command multiple times. The command is IP DHCP excluded address, the low end, or the high end. Now, if you just put the low end, then you're excluding one address. In this case, they excluded a range of addresses 1 through 9, and also the address 10. So they have 11 addresses that have been configured. I think that's 11. And yeah, it should be 11. And no, that's 10 addresses. I'm sorry, that's 10 addresses. So it's 1 through 10 is 10 addresses. Yeah, there's 10 addresses total, 9 here and then 1 here. Now, if I want to point out that why you would want to separate, say, the last address in a range of addressing, 254, that would be perhaps, well, not quite the last, 255 is the last one, but the last assignable host address is 254 and a /24 network. The 254 address would be often assigned to the router interface. Then addresses 1 through 9 could be assigned to, say, printers, scanners, webcams, anything that you don't want the address actually changing on, IP phones. You would assign a static address. That way, that address can be remotely accessed. Just the other day, I had my IT department configure a color printer, and they were able to just sign into it with a static IP address to the printer for the configuration. If it wasn't a static address, if every time the printer came online it asked for a new address, that would be much more complicated. So that makes sense to first exclude the addresses. If the way I remember it, and why you would want to start with excluding addresses, is once you create a pool and turn it on, those addresses can now be handed out, right? So if you do the pool first and you start handing out addresses, now you might hand out an address that you're expecting to be part of the excluded address, something you want to statically configure, like a printer. So you really need to exclude the addresses first and then create the pool. One more thing, if you don't want a range of addresses, again, you just use one address. If you want a range, it's the low end and then the upper end, the high end, and then that's the range. 1 through 10 in this case will all be excluded and will not be part of the pool. The next step is to define the pool. You give it a name first, and the name is, the command to create a name is IP DHCP pool, then whatever name you want. And that will create a pool with the specific name plus the router in DHCP. It will put the router in DHCPv4 configuration mode, which is identified by the parameter router DHCP config, interface configuration mode, right? So we have, next slide. So the third step is to configure the DHCP pool itself. The address pool and the default gateway router must be configured. Use the network statement to define the range of available addresses. Use the default router command to define the default gateway. These commands and other optional commands are shown below in the table. So let's take a look at that table. We have to define the address pool, its network, and then the network address. Here's the example. So whatever network you're creating your pool by, in this case it's the 10 network, and the subnet mask or the prefix line. So you can do 255.255.255.0, or you can do /24. Then you identify the default rated router or gateway, and that is default router, and then whatever the address is, just the IP address, and then you can, it's an option, define the DNS server and here it is. You give it an IP address. Define the domain name. Now that is a requirement. Actually, I think this is a requirement too. Yeah, I'm sorry. That is a requirement, is to define the DNS server. So you give it a server, you give it a domain name, and the domain name can be anything. And then you can define the duration of the DHCP lease. And I'll show you what this looks like, days, minutes, hours, in the next slide. So hang on just a minute. And then define the net bias win server, net bias name server, and that is an optional command, really beyond the scope of this class. So the way you set time, you type the word lease, and then whatever the number, in this case, 1 day. Or you can do an hour. If you want to just make it an hour, you can make it 1 hour. If you want to make it 1 minute, 1 minute. That would be ridiculous. So you could actually have 111. That would be 1 day, 1 hour, 1 minute. They're just showing you the break. So the first position is days, second one is hours, third one is minute. And the following example shows an infinite, unlimited lease, and that is lease and then the word infinite. And there might be times you want to set an infinite lease, but if that happens, it absolutely cannot be something that changes on the devices cannot change on a regular basis. So if you picture, you would never want to do it on laptops, for example, because any laptop that comes into range that gets an IP address would automatically keep that IPv4 address indefinitely, and you would run out of addresses. On the other hand, inside of a lab, there's 24 computers, and you want to set, you don't want those 24 computers to be changing IP addresses every time they turn on. Why, right? They're the same computer. You can make it an infinite IP address for those computers. There's no reason to keep changing out the IP address. For 24 computers in a class, those 24 don't change. Now, of course, if you come, you're going to remember that. If you come in and you take out the computers, just like they did in a lab at the school recently, they took out the old 24 computers every 3 years. They put in 24 new computers. Now those old computers still have leases. You really needed to release those leases to end the lease, and the last slide in this presentation tells you how to do that. Or just don't use an infinite lease. Use just a longer. Use a year lease or something, 365-day lease. So here's an actual example of the configuration that's been done. So IP DHCP excluded address. Here is the beginning of the range, the end of the range, and then here we have the top of the range. So we have 10 total addresses. And then why do I suffer with that? We have 11 total. No, we have 10 total addresses. We have 10 total addresses. I'm just counting my fingers, right? 1 through 9, and then we have 10. So we have 10 addresses. Anyways, then we create our pool, IP DHCP pool LAN, and then we named it LAN pool 1. Now you do not have to make it all capital letters, but it is convenient later when you're looking at your running configuration and you see LAN pool 1 in all caps. It's easy to identify that as the name of the pool. Not required, but it is helpful. Then I want you to notice you have to give it the network, and the first command is the word network, right? So just go with it, right? I asked my teacher when I took the class, why is it network? Why isn't it subnet? And she said, well, there's a lot of commands that work with network, and I said, well, how about if we just get rid of that word completely and we just type in the network, right? And she said, well, that's not the way it works. And I said, maybe that's the way it should work. And she said, but it's not. And so it's like, okay, so this is the way it is. You have to remember to type the word network. Now, if you can't remember to type the word network, just put a question mark after the pool name over here, or put a question, actually put it not after pool. That would give you options after pool. it'll go into IP configuration, I'm sorry, pool configuration mode. I'll put the question mark here and it'll give you options, and then you'll see the word network, and then you'll say, okay, I got it, network. And then here, default router, same thing, another question mark, default, I don't know how you're going to remember that, why it doesn't say gateway or something, I don't know, but it says default router, so put the question mark there if you forget it, it's not a big deal. Then DNS server, here's a domain name, give it an example, and then N to get out of it. And that is how you configure a route, a DHCP server to hand out IPv4 addresses. That's it. That's the command. That's what it looks like. Not more complicated than that. There are some show commands to verify. The first one is show the running configuration. Second one, and that displays the commands that you've entered on the router. Then show IP DHCP binding, and that displays a list of all IPv4 addresses to MAC address bindings provided by the DHCPv4 service. So that, in other words, tells you what IPv4 addresses that have been handed out. And then show IP DHCP server statistics. That displays the count information regarding the number of IPv4 messages that have been sent and received, the handshake, if you will. This is what it looks like. So here you can see the exact same commands we just entered by going to show running configuration, and you can check to see if you maybe made a typo someplace if you're running into problems, if it's not working. Here's the show IP DHCP binding, and you can see here is an address that was handed out. This is the IP address, 10.10 was handed out, which is the first one in the range of the pool, remember? And then it's bound to this MAC address, and when it was assigned, and then it was assigned automatically, which is the purpose of DHCP. Show IP DHCP server statistics. It shows the handshake. So down here at the bottom, you can show DHCP discover, request, and none were declined, none were released. You can, on the PC, the client, you can take a look at this as well by going to ipconfig/all, and you can see the domain that's been connected, the IPv4 address has been handed out, the default gateway has been handed out, and the DNS server were handed out, and anything else that was handed out. Now, this is not a hard concept, but it is something you have to understand. In a complex hierarchy, in a complex network, enterprise servers usually are located centrally. These servers may provide DHCP, DNS, FTP, and TFTP services for a network. Network clients are not typically on the same subnet as those servers. In order to locate the server or receive services, clients often use broadcast messages. Now, as we know, broadcast messages don't pass from the routers, don't pass broadcast messages. So we have to get from this PC, we have to get to a DHCP server on another network, right? So PC1 is attempting to acquire an IPv4 address from a DHCPv4 server using a broadcast message. In this scenario, R1 is not configured as a DHCPv4 server and does not forward the broadcast because they don't forward broadcast messages. Because the DHCPv4 server is located on a different network, PC1 will not receive an IP address from the DHCPv4 server. It must be configured, R1 must be configured to relay the DHCPv4 messages to the DHCPv4 server. Relay. We must relay that address. What we call it is a helper address. A Cisco iOS helper address is configured so that the router acts as a relay agent forwarding the message to the DHCPv4 server. It's placed on the incoming interface. That makes sense as well, because in order for broadcast messages from here to be sent past the router, well, it can't be. But so we need would be blocked here. So we need to put the helper address right here in order for R1 to know where to send the request for an IPv4 address. So it's configured right there. And what is the configuration? Well, first you sign into that interface G000 in this case, and the command is IP helper address, and then whatever the IP address is of the DHCP server. Now, let's read through this. You have to configure R1 with the IP helper address, and then whatever that address is on that incoming interface within the network. This will cause R1 to relay DHCPv4 broadcast to the DHCPv4 server. As shown in the example, the interface on R1 receiving the broadcast from PC1 is configured to relay the DHCPv4 address to the DHCPv4 server at 192.168.11.6. When R1 has been configured as a DHCPv4 router relay agent, it accepts broadcast requests from the DHCPv4 server and then forwards those requests as a unicast to the DHCP, the IPv4 address, or to the IPv4 address 192.168.11.6, which is the DHCP server. The network administrator can use the show IP interface command on that interface. So you go to show IP interface and then G000 in this example, and then what you're looking for is the helper address being assigned. Other service broadcast related, in addition to the IPv4 broadcast for a IPv4 address, you can also, the IP helper address can also, on port 37, it can forward time, TACTAS on 49, 53 DNS, DHCP server, we don't use boot P anymore, TFTP on 69, 137 NetBIOS, etc. Now you can also disable the Cisco iOS server, and the command to do that is no service DHCP. So use in global configuration mode, and if once disabled, to re-enable it, you have to turn it on by typing service DHCP. Note, clearing the DHCP bindings or stopping and restarting the DHCP server may result in duplicate IP addresses temporarily assigned to the network. And the way that might happen is that pool of addresses is already handed out 10, 11, and 12, for example. When you stop the service and turn it back on again, whoever has whatever hosts have 10, 11, and 12, they maybe have not called back to request a replacement, the renewal of the address, and so they just keep trucking along with 11, 12, and 13. Now that pool starts handing out addresses, it's going to start at 10, so it hands out 10. There's already a 10 out there. That creates a problem, and you're going to get an error message when that happens, indicating that the address is already in use. Now, we just talked about the router handing out addresses, but sometimes the router is the client and it needs an address. For example, your router, when you connect to the ISP at home, your router is not going to assign its own address for the server. It's going to ask the server, AT&T or Comcast, whoever, it's going to ask the server for an address. So the router is actually, in this case, the client. So, and that's what it says there. In these instances, you can configure a Cisco iOS router as a DHCPv4 client. Sometimes the Cisco routers in a small office or home office and branch sites have to be configured as a DHCPv4 client on a port in a similar manner to client computers. The method used depends on the ISP. However, in the simplest configuration, the Ethernet interface is used to connect to the cable or DSL model. To configure the Ethernet interface as a DHCP client, use the IP address DHCP interface configuration mode command. Now, the term that's key here is, let's see what that looks like. Let's read that last line. In this figure, assume that the ISP, here's the ISP out here, and this interface, instead of giving it an IP address, because you don't know what the IP address, the ISP is going to give you an IP address. So you have an idea because when you turned off your router, you had an IP address in this network, possibly, but you don't know if you're going to get that same address when you turn on the port. So you're asking for it. Now, we have been here many times. Interface, you go into the interface, right? And here's the command. Now, this is super, super easy to remember. That's it. That's the whole command. This is the whole thing. You also have to, nope, that's it. That's the whole thing. So I want to, the way you think about this DHCP over here is normally when we go into this port, we type, when we're assigning an IP address, we type IP address and we type in the IP address in the subnet. Well, in this case, we are letting somebody else control that. So we're typing IP address and then just DHCP. That sets the router as the client, and it starts the handshake with the ISP server saying, hey, I need an address. The whole DORA thing I was telling you earlier. And the ISP says, oh, yeah, here's an address. Or maybe you have multiple servers saying, here's several addresses. And then you pick one, and then you broadcast it back out, and then they respond acknowledging it, right? So again, it's really easy to remember to set a router as a client in this situation. You just, instead of giving it an IP address, you just type in the words DHCP, and it will configure, it will reach out and get its own address. I hope that helps. Again, when I went through the class, this was the only thing in DHCP that was a little fuzzy for me, because on this side of the router, it's handing out addresses, right? It can do both. This port, it is the interface to the world, and the server is giving it addresses. But the network here, all of those addresses, we're going through the pool and everything else. That's on this interface on the other side, handing out addresses. So the router can be both. It can be handing out addresses on this side, and it can be requesting on that port. We'll leave that there. Show IP interface G01 will show you that it has an IP address. So here we went into this interface and we're showing it, and look, it has an address. Well, where did it get the address? It got the address by DHCP, an address determined by DHCP. Okay. You can also set a home router, as I mentioned before, and you have, and I know you have, just by setting it to auto configuration DHCP. We used to go in and set a home router to be with static addressing, and we also have done it with a pool, but it's much more realistic to see a home router is using the DHCPv4 client. And I bet you if you go look at your router at home, you will see that it is set up for automatic configuration. You are going to do a packet tracer on this, 7.2.10. A 7.4.1, you're going to implement DHCP, and you're going to do a lab where you are implementing DHCPv4, and you're going to have fun with that. You get to start from the beginning by building it. So as I just showed you, it is not that challenging. IPv4, hopefully with the comments that I've made to you, IPv4, DHCPv4, not very challenging. Write down the commands. Remember, you've got to create, you've got the only challenge that I'd say is remembering you have to do your excluded addresses, and you have to then create your pool, and then remember the word network is in there, and then the fact that you can be dynamically handing out addresses on your network side, where you have all your PCs connected, and then you are the client on the other side talking to an ISP and asking it for an address. Hopefully, you write down these commands inside of your tech notebook. They'll be helpful not only here, but down the road when you're actually doing this in a production network. All right, good. If you have any questions, please wait just a moment, and I'll give you a moment or two to ask questions if you're here with me live. If you are watching this and you're in my NetAcad classroom, ask your questions in the help discussion forum, and we've all promised to help each other out. And if you're watching it inside of YouTube, please ask questions down below in the comment section. Also, please like and review, like and follow, and I really appreciate that as well. And I will see you in just a moment. If you were here with me live, don't go anywhere. Don't go anywhere. We've got one more presentation. For the rest of you, I'll see you in the next presentation. Thank you for coming to class. And I hope you have a great week. I'm going to end this now.